the overall response for the BJT amplifier. Now we have three frequency, which are FLE, FLC, and FLS that obtained from the voltage divider configuration. This is my example. Okay, previous example is voltage divider. For the whole system, okay, now the lower cut-off frequency, okay, which is FL, will be the largest value of all the three low frequencies. Okay, which means that we have to compare these three capacitors, which one has the largest value. Okay, which one has the largest value? The largest value will become the cut-off frequency. Okay, at this time we say that this is the frequency response for the low. Okay, and the cut-off frequency is this one. Okay, either from these three frequency. When the FL has been determined, then sketch the asymptotes for three frequency, for FLE, FLC, and FLS. Remember, the asymptote has 20 dB per decade. It means its slope, okay, its slope is 20 dB per decade. Then finally, draw the actual frequency response. Actual frequency response means it's a curve, the gain that you get for the gain, okay, in the frequency plot. Then sketch of the asymptotes and the actual frequency response will be explained in the next example. Okay, we go to this example. Okay, see, for this question, first calculate mid-band gain AV. Okay, remember that mid-band gain, when AV we get equal to 1 or AV equal to 0 dB, and AVS. So what is the AV here and AVS? AVS means V out over Vs. Okay, we measure the voltage from V out until Vs. Okay, B, calculate low frequency response and determine the lower cut-off frequency for the voltage divider network using the following parameters. Okay, for the low frequency here, now we have check all capacitor value is here. Okay, and C, sketch the asymptotes and the low frequency response, which is the actual response, using a what? Plot. Okay, the semi-log graph. So this is the voltage divider, and this circuit, the voltage divider has a complete circuit. It has RS, and it has RL, and it has VS. Okay. Solution. Calculate the mid-band gain. So the mid-band gain we can get, okay, first determine the RE for the DC condition. Okay, remember that for the voltage divider, you have two methods to solve. First, using the exact analysis, and another one is approximate. If you want to use the approximate method, please check this condition. So beta RE must be greater 10 times of the R2. So when I calculate this, beta RE, we get 200 kilo ohms, and 10 times R2, we get 100 kilo ohms. So this condition is satisfied. Okay, satisfied. So I can use approximate method. What do you mean by approximate method? approximate method here, you can say that to get the VB, we can directly using the VTH. Okay, means that at this time we can ignore the I that flow at R1 and I that flow at R2. We can say it is same. So the IB, we can say that it's almost to 0. That's why we can use this equation directly to get the VB. Okay, so now we calculate the VTH. So the VTH, we get the voltage divider using voltage divider equation now, and insert the value and you get 4 volt. Okay, for the IE, okay, because you already get the VB, now you can get the VE here. Okay, so VB you get from this. VBE is VB minus VE. So VE equal to VBE. VBE, sorry, VB minus VBE. Okay, so this is VB minus VBE, and we get VE. So you find IE. Okay, and then after that, get the RE. Okay, so 26 millivolt divided by IE, we get 15.76 ohm. The beta RE, okay, multiply with 100 for the beta, we get 1.576 kilo ohm. Okay, then for the mid-band gain, we derive the equation. Okay, we don't know what is the equation for the AV. Okay, now the AV is a loaded. Okay, I can say a loaded gain because we have RL. So in this method, I directly include the RL in the equation here. So at the output side, okay, this is the Z out. Okay, V out is equal to negative IC, okay, multiply with RC parallel RL, and the IC is equal to beta IB. Okay, this is equation 1. Okay, for the equation 2, V in equal to IB beta RE. Now we get V out over V in. So you get this. This is the equation for the loaded gain AV. Now the equation the answer is negative 90. Okay. Then from the question, ask you to calculate the AVS. AVS, we know that V out over Vs. Okay, for the AC equivalent circuit, now we get Z in. Okay, R1 parallel R2 parallel beta RE. So the value is here 1.32 kilo ohm. Then for the V, okay, this equation is at the input side where you get your Vs here, and then you have Rs. Okay, the capacitor here is a short circuit, and then you have R in here. Okay, so V in is here, V in. So this is the voltage divider. Okay, for V in here, voltage divider. So you get R in multiply with Vs divided by R in plus Rs. Okay, then you see here is Vs, okay, and this is Vin. So we want Vin over Vs, okay. So it become Rin over Rin plus Rs. So for this Vin over Vs, I get 0.568 ohm. Okay. Then this value insert into here. Okay, because we know that, okay, the AVS is V out over Vs. So V out over Vs, we will get from V out over V in multiply with V in over Vs. That's why you have to calculate this first. Okay, because you already have V out over V in. So in this case, the voltage divider is a loaded gain, okay, with RL. Okay, so this is from the previous calculation. We get the AVL here, and this is the new one. And finally, AVS is negative 51.21. Okay, you see. Okay, we can see that here the AVL is negative 90, AVS negative 51 and 21. You can see the difference during the loaded gain. Okay, the gain is still high. However, during for the total gain, we get the gain is a little bit smaller. So negative 51.21. Okay, means that now AVL is greater than AVS, and AVNL much be greater, okay, than the AVL. Then we calculate the frequency response, FLS. Okay, FLS means that at the capacitor CS. CS, okay, where the CS? CS is at input side. So the impedance now, ZCS. From the circuit, we have RS. So the total is RS plus Rin. We get this value. Okay, this Zin we calculated already. Okay, we get here. So final, the impedance is 2.32 kilo ohm. Then for the FLS, just insert this impedance and the CS. So you get this. And finally, value is 6.86 Hertz. Next, we calculate the FLC. Okay, where is the FLC? This is the output side with the CC. Okay, so output side we have Z out. Our Z out now is RC, because okay, for the voltage divider, the Z out is R out, RC. But for this question, the R out is infinity. So that's why we get RC here. So total, the impedance here is RL, because we have RL plus with R out. Okay, so 6.2 kilo ohm. Okay. So now for the FLC, we get insert the impedance here and the capacitor here. So you will get the FLC is 25.68 Hertz. Then for the third frequency, FLE, so this at the RE. Okay, so RE, we need use formula for this RE. Okay, remember this RE. So RE parallel with R prime RS prime divided by beta plus RE. So this R prime is here. RS parallel with R1 parallel with R2. Okay, because we are using voltage divider. Okay, the R1 and R2, this is because of the voltage divider. You have to change it to another. If you change another circuit, so it might affect at this area, this value. Okay, then insert this RE into the impedance here. Now you get 24.35 ohm. Then calculate the FLE, insert the ZCE and CE here. I mean, this is the RE, so you get 327 Hertz, okay, for the FLE. Now we already have three frequency. Okay, these three frequency. We compare the three frequency. Which one is the highest or which one is the largest value? So the largest value is the FLE with the 327 Hertz. Means that it will become the cut-off frequency. Okay, the cut-off frequency.